Welcome everyone. Today I will be taking you through this entire video on an overview to DevSecOps. First of all, let's move to the agenda. I will begin by understanding why we need DevOps. Everything exists for a reason. So I will try to figure out that reasons. We are going to see what are the various limitations that the traditional software delivery methodologies and how with DevOps overcome all of those limitations. Then we are going to focus on what exactly is the DevOps methodology and then what are the various stages and tools involved in DevOps. And then secure software onboarding, secure build automation, continuous delivery release automation, production monitoring and ongoing. So I hope you all are clear with today's agenda. Why DevOps? Let's move to the waterfall model. Now, before DevOps, organizations were using this particular software development methodology. It was first documented in the year 1970 by Royce and was the first public documented life cycle model. The waterfall model describes a development method that is linear and sequential. Waterfall development has distinct goals for each phase of development. Now, you must be thinking, why the name waterfall model? Because it's pretty similar to waterfall. Now, what happens in the waterfall? Once the water has flowed over the edge of the cliff, it cannot turn back. So, same is the case for waterfall development strategy as well. An application will go to the next stage only when the previous stage is complete. So, let us focus on what are the various stages involved in waterfall methodology. So, notice the diagram that is there in front of screen. If notice, it's almost like a waterfall, or can even visualize it as a ladder. So, first what happens, the client gives requirements for an application. So, you gather that requirement and you try to analyze it. Then, design the application, how the application is gonna looks like. Then you start writing the code for the application and you build it. Then it involves multiple times compiling your application and unit testing. Then even it involves packaging as well. After that, it's deployed onto the test servers for testing and then deployed onto the broad service for release. And once the application is fine, it's monitored. Let me give you a few disadvantages of this model. So here are a few disadvantages. So first one is, once the application is in the testing stage, it's very difficult to go back and change something that was not well brought out in the concept stage. Now, what I mean by that, support, you have written the code for the entire application, but in testing, there is some bug in that particular application. Now, in order to remove that bug, you need to go through the entire source code of the application, which used to take a lot of time. So, that is very big disadvantage in waterfall model. Apart from that, no working software is produced until late during the life cycle. We saw that when we are discussing about various stages of what for more there are high amount of risk and uncertainty, which means that once your product is fine, it's there in the market. Then if there is any bug or any downtime, then you have to go through the entire source code of the application again. You have to go through the entire process of waterfall model that we just saw in order to produce a working software again. So that show it used to take a lot of time. there is a lot of risk and uncertainty, and imagine if you have upgraded some software stack in your production environment and that led to the failure of your application. Now to go back to the previous stable version used to also take a lot of time now. It is not a good model for a complex and object-oriented project. It is not suitable for the projects where requirements are at a moderate to high risk of changing. So, what I mean by that, suppose your client has given you a requirement for a web application today. Now you have taken on time and you are in the condition that release the application. Say after 1 year. Now after 1 year, the market has changed. The client does not want a web application. He is looking for a mobile application now. So this type of model is not suitable where requirements are at a moderate to high risk of changing. Now we are going to focus on the next methodology, that is called the Agile methodology. Now, Agile methodology is a practice that promotes continuous iteration of development and testing throughout the software development lifecycle of the project. So, the development and the testing of an application used to happen continuously with the Agile methodology. So, what I mean by that, if you focus on a diagram that is there in front of your screen, so here we get the feedback from the testing that we have done in the previous iteration. We design the application again, then we develop it there again, we test it, then we discover few things that we can incorporate with the application. We again design it, develop it, and there are multiple iterations involved in development and testing of the particular application. In Agile methodology, each project is broken up into several iterations and all iterations should be of the same time duration and generally it's between 2 to 8 weeks. And at the end of each iterations of working product should be delivered. So, this is what Agile methodology in a nutshell is. Now, let me go ahead and compare this with the waterfall model. Now, if you notice in the diagram that is there in front of your screen, so waterfall model is pretty linear and it's pretty straight as you can see from the diagram that we analyze requirements. We plan it, design it, build it, test, and then finally we deploy it onto the processor was for release. But when I talk about the Agile methodology, over here the design, build and testing part is happening continuously. We are writing the code, we are building the application, we are testing it continuously. And there are several iterations involved in this particular stage. And once the final testing is done, it's then deployed onto the broad service for release. So, Agile methodology basically breaks down the entire software delivery life cycle into small iterations that we call it, due to which the development and the testing part of the software delivery life cycle used to happen continuously. Let's move forward then. We are going to focus on what are the various limitations of Agile methodology. So the error that I was talking about due to the application is not working fine. I mean, once your application is fine and you do some software stack in production environment, it doesn't work properly. Now to go back and change something in the production environment used to take a lot of time. For example, you have upgraded some particular software stack and because of that your application is not working, it fails to work. Now to go back to the previous stable version of the software stack, the operations team was taking a lot of time because they have to go through the login script that they have written on in order to provision the infrastructure. Now we are going to look at the solution to all the problems that we have just discussed, and the solution is none of other than software development strategy which bridges the gap between the dev side and ops side of the company. So DevOps is basically a term for a group of concepts that, while not all new, have catalyzed into a movement and rapidly spreading. Throughout the technical community, like any new and popular term, people may have confused and sometimes impressions of what it is. So, let me tell you, DevOps is not a technology. It's a methodology. So, basically, DevOps is a practice that equated to the study of building, evolving, and operating rapidly changing systems at scale. Now, let me put this in simpler terms. So, DevOps is the practice of operations and development engineers participating together in the entire software lifecycle, from design through the development process to production support. And you can also say that DevOps is also characterized by operation staff making use many of the same techniques as developers for this system work. I'll explain you that how is this definition relevant, because all we are saying here is DevOps is characterized by operation staff making use many of the same techniques as developers for their system work. I will explain you infrastructure as code. You will understand why I am using this particular definition. So, as you know, that DevOps is a software development strategy which bridges the gap between the dev part in the upside of the company and helps us to deliver good quality software in time. And how this happens? This happens because of various stages and tools involved in DevOps. So, here is a diagram which is nothing but an infinite loop, because everything happens continuously in DevOps. Everything is starting from coding, testing, deployment, monitoring. Everything is happening continuously. And these are the various tools which are involved in the DevOps methodology. So, not only the knowledge of these tools are important for a DevOps engineer, but also how to use these tools, how can I architect my software delivery lifecycle such that I get the maximum output. It doesn't mean that if I have a good knowledge of Jenkins or Git or Docker, then I become a DevOps engineer. No, that is not true. You should know how to use them. You should know where to use them to get the maximum output. So, I hope you have got my point. What I am trying to say here in the next slide to be discussing about various stages that are involved in DevOps. So, let's move forward, and we are going to focus on various stages involved in DevOps. So, these are the various stages involved in DevOps. Let me just take through all these stages one by one, starting from version control. I will give you an entire picture of these stages in one slide first. So, version control is basically maintaining different versions of the code. What I mean, By that, suppose there are multiple developers writing a code for a particular application. So, how will I know that which developer has made which commits, at what time, and which commit is actually causing for error? And how will I revert back to the previous commit? So I hope you are getting my point. My point here is, how will I manage that source code? Suppose developer has made a commit and that commit is causing some error. Now, how will I know the developer has made that commit and at what time he made that commit? And the third was that editing happened. So, all of these questions can be answered once you use version control like GitHub version. So, then we have continuous integration. So, continuous integration is basically building your application continuously. What I mean by that, suppose any developer made a change the source code, a continuous integration server should be able to pull that code. I am prepare a build. Now, when I say build, people have this misconception of only compiling the source code. It's not true. Includes everything starting from compiling your source code, validating your source code, code review, unit testing, integration testing, etc. And even packaging your application as well. Then comes continuous delivery. Now the same continuous integration tool that we are using, suppose Jenkins. Now what Jenkins will do, once the application is built, it will be deployed onto the test server for testing to perform. User acceptance test or end user testing, whether you call it, there will be using tools like Selenium for performing automation testing. And once that is done, it will be then deployed onto the process servers for release. That is called continuous deployment. And here we will use in configuration management and tools. So this is basically to provision your infrastructure. Continuous deployment is something which is not a good practice, because before releasing a product in the market, there might be multiple checks that you want to do before that. There might be multiple other testing that you want to do, so you don't want to do automated. That's why continuous deployment is something which is not preferred after continuous delivery. We can go ahead and manually use configuration management tools like Puppet, Ansible, or we can even use Docker for a similar purpose, and then we can go ahead and deploy it onto the crossovers for release. And once the application is live, it is continuously monitored by tools like Nagios or Splunk, which will provide the relevant feedback to the concerned teams. So, these are various stages involved in DevOps. So, now let me just go back to clear as summarize. So, this is our various stages that are used in DevOps. So, we have Jenkins here. We have a continuous integration server. So, what Jenkins will do, the moment any developer makes a change in the source code, it takes that code and then it will trigger a build using tools like Marvel. Once that is done, it will deploy it onto the test server for testing, for end user testing using tools like Selenium. Then what happens, it will automatically take that tested application and deploy it onto the process servers for release. Then it is continuously monitored by tools like Nagios. So Jenkins is basically heart of DevOps lifecycle. It gives you a nice 360-degree view of your entire software delivery lifecycle. So, with that UI, can go ahead and have a look how your application is doing currently. We are in which stage. It is in right now testing is done or not. All those things you can go ahead and see in the Jenkins dashboard. There might be multiple jobs running in the Jenkins dashboard that you can see, and it gives you a very good picture of the entire software delivery life cycle. Introduction to DevSecOps. DevSecOps is new. Gartner published its first report on DevSecOps in May 2016. Stakeholders of the Agile and DevOps movements are passionate about change. When any movement is new and is still evolving, there may be disagreement about particulars. DevOps and DevSecOps are about culture. Culture is defined as the attitudes and behavior of a particular social group. Many believe that culture change is necessary for large organizations to sustain ongoing process improvement. An individual's role and background influence their interest in different aspects of DevSecOps practice. Traditional IT departments are fragmented, with development, security, and operations all having different leadership and reporting structures. Process experts and coaches often say that DevOps is not about tooling. Engineers and technologists grow tired of process quickly and want real-world examples of how process can be implemented. Executive stakeholders measure outcomes and results when making investments in process improvement. To achieve the goal of DevOps, quality software must be developed and deployed faster. DevOps automation. DevSecOps can be used to enforce proper cybersecurity practices within an automated DevOps CI/CD pipeline. These are software version control, continuous integration, continuous testing, configuration management and deployment, continuous monitoring, containerization, and container orchestration. Measuring DevOps success. Deployment frequency, fast and frequent release, decrease load time, go to cache cycle, detection of threats, vulnerabilities and malware, mean time to repair and remediation, efficiency of rollback and recovery. What is DevSecOps? In the past, deployment, security and operations were separated departments. Security has been the role used to enforce regulatory, governance and other compliance measures. DevSecOps is a portmanteau mashup of development, security and operations. It is a process used to help organizations improve the time-to-time market and release software faster. DevSecOps workflow. This figure is showing DevSecOps overall process with continuous integration and continuous deployment. The application is developed by planning, coding, and building. Then it goes to the QA team, and they will do a continuous quality process. Then move to automated deployment and continuous monitoring. After all processes, they will get the feedback from customers. If they want to change the requirement, then it will go to continuous improvement phase. This process is called CI/CD pipeline with continuous integration and continuous delivery. Security practices. Server hardening. Server hardening practice is used to enhance the server security. OpenSCAP application can be used to serve vulnerabilities to mitigate risks. Application hardening. Application hardening practice is used to enhance the application security. It is working with the integration of third-party application through APIs. Identity and Access Management. IAM or Identity Access Management is involved to authentication, authorization, user management, and credential repository via security and the automated framework. Clean repositories. Software onboarding is the process developers use to acquire the third-party components needed to develop and compile an application. With the rise of open source, many third-party component libraries and frameworks are acquired from public repositories. In some cases, off-premises repositories are not administrated or maintained by the developers' organization. Attack vectors are often exploited in public systems. Since the systems are not on-premises, they must be hardened and maintained by the organizations that provide them. Malware exists in most public repositories, and some of the most popular software components in use today are known to be vulnerable. Firewall can be implemented in the internal system to prevent from the outside attack. Securing public repositories. GitHub is a useful and popular off-premises repository used by many organizations because it is one of most well-developed repository in use today. Threats facing GitHub. Sometimes files checked into GitHub inadvertently contain login credentials for other internal or external services. In many cases, developers are granted access to company repositories from their personal or corporate email account. Overcome security issues using GitHub. Threats monitoring for GitHub. DevSecOps practitioners can take practical steps to tighten security when using public repositories. Clean up login credentials. Developers should be careful with their GitHub login credentials. It is best to limit access to only those developers who are involved in a given project. When developers leave a project, their credentials should be revoked. Maintain and administer repository setting. Monitor GitHub for suspicious activity. Aggregate and analyze GitHub logs. Secure containerization. Containers are specially formatted files that can contain executable applications, programs, modules, and the code libraries that they depend upon. They isolate an application from other applications from the operating system and hardware. Containers help ensure that the versions of libraries within the container do not mandate patching and upgrade that might affect other applications in other containers. Developers can search for a variety of container images using Docker Hub. While Docker Hub is a public repository, it contains public, private, and official images. Public images are shared amongst broad community. Private images might be limited to a single organization or even project within an organization. Official repositories are certified repositories from independent software vendors and Docker contributors such as Canonical, Oracle, Red Hat, and others. If repositories could contain malicious code or libraries, then the Docker contents will be infected by it. Docker Trusted Repositories. Trusted registries are secure, managed repositories. A registry is a data store that contains metadata. Example, data about data. A repository contains the actual content of interest. Trusted repositories use a digital signature to indicate which content in the repository is safe. Software publishers digitally sign their content when it is published. Developers can use systems that verify digital signatures prior to downloading content. Provisioning with fast tooling. Provisioning means providing something for use. In DevSecOps, the process of providing the developer with the software needed to develop an application is automated. It's important to ensure that the same software the developers use is provisioned in the test, staging, and production environment. Complex systems require automation to ensure that provision processes and components remain uniform and managed. Shift left is a process change in which operations and engines teams shift processes upstream to developers. Platform as a service offering provide developer platform and infrastructure via self-service tool and automation. Fast systems facilitate the development of templates. OpenShift is an open source fast offering from Red Hat. Secure build automation. Jenkins. Jenkins is a popular open source build automation system. Jenkins originated from the open source Hudson project. Jenkins is highly extensible and supports hundreds of plugins that handle build tasks. Jenkins supports continuous integration by integrating with source code management tool. Jenkins supports webhooks that automatically trigger a build processes when developers check in modified application source code. OWASP Dependency Checker. OWASP Dependency Checker is an open source scanning system. Dependency check can be run from the command line or through an automated build program such as Jenkins. Dependency check maintains the downloaded CVE database. Dependency check provides human-readable and machine-readable reports. Continuous delivery release automation. Automated deployment. Automated deployment is critical to ensure control and consistency when promoting workload into production environment. Continuous delivery release automation (CDRA) practice and tool are used to promote the workload into the upper environment. Continuous delivery release automation (CDRA) has two categories: application release automation, application release orchestration. Automated deployment, Deploy Hub. Automated deployment tooling varies widely in capability and level of implementation. Deploy Hub is an open source solution that is hosted as a SaaS solution as well as being offered for on-premises implementation. Deploy Hub provides a means of integrating deployment with Jenkins build automation, the Nexus repo, and may use Ansible playbooks and actual deployment. Configuration management using Ansible. Configuration management is practice and tooling required to fully automate the process of configuring target environments and deploying application workload to them. Ansible is an open source configuration management tool from Red Hat. Ansible utilizes playbooks to deploy both systems level and application level components to target environment. Ansible uses YAML files known as playbooks to automate deployment. Playbooks have the ability to test state on target platforms and only perform those configuration and installation steps necessary to enable the workload. Ansible performs its work in a predefined chronology to ensure dependencies are met. Production monitoring and ongoing. Production monitoring. Continuous monitoring is the ongoing automated evaluation of workloads to assess their health and function. Production monitoring may include threats detection, vulnerability detection, and malware prevention. Since the new threats and vulnerabilities are developed and discovered over time, it is important to monitor applications through their entire lifespan, not just while they are under development. When applications need to be refactored or upgraded with third-party libraries, feedback loops and automated reporting notify the development team that vulnerabilities or other defects require attention. Static application testing. Static application testing is used to test for new vulnerabilities that have become known since an application release into production. Dynamic application security testing. Dynamic scanning uses black box security testing methodology. Conclusion. DevSecOps is relevant to all aspects of modern software development and deployment. Whilst the high speed of development and deployment, some security risks still exist in DevOps. This video illustrates the impact of DevOps on software security from both risk and opportunities aspect with the use of tools. Thank you.